Okay, let's go through an example. Suppose we have a bearing design problem, and we know that the L10 life is 10 to the 6 revolutions, and the design life that we'd like is 5,000 hours. And that is based on the speed of 1,725 rotations per minute. Now, let's suppose the design force is 400 pounds force, and the reliability is 90%. And of course, remember that right now we're not dealing with different levels of reliability. We are assuming that the reliability in these problems at the moment is always 90%. We're only looking at the relationship between force and life. So our job is to find the catalog load rating so that we can choose an appropriate bearing from a catalog. Also, here we can assume the bearing is a ball bearing. And if you remember, that means the exponent, or this parameter that we use in the exponent a for a ball bearing, that is equal to 3. So if we go through and use the formula, C10, that's equal to F sub D times L sub D times N sub D times 60, divided by the same for the catalog data, except here we know that combined is just equal to the L10 value. Then all of that is raised to the power of 1 over A. Plug everything in, we get 400 times 5,000 times 1725 times 60 divided by 10 to the 6th to the power of 1/3. So let's have a look here. The numerator up here, if we were to multiply that out, it's actually much larger than the L10 life. Remember, the L10 life is typically a rather short life for bearings. So because we have a much longer life than the L10 rating, then that means we can expect that we need to select a much stronger bearing, or in other words, the catalog load rating, that's going to be a lot higher than 400 pounds. If we multiply all of this out, solve for the C10 value, it turns out that it's 3,211 pounds force. So that's much larger than the catalog load rating. So write that out. It's much larger. The catalog load rating is much larger than the force that will actually be applied. But the reason we need to select a much stronger bearing is because we want a longer life than 1 million revolutions. Or in other words, L sub D is much larger than the L10 life value.